How recycled car is made. What if I told you the steel in a new skyscraper was once the family car that took you to school? In the next few minutes, you'll watch an old vehicle lose everything: fluids, glass, wiring, until there's nothing left but raw potential. And then it's reborn. Stay with me, because the most dramatic moment happens after the car is crushed. It's not the end, it's the beginning. The second life begins. Every car has two lives. The first one is obvious: miles, memories, maintenance. The second life starts right here, at the gate of an auto recycling facility. This place isn't a graveyard, it's an industrial launch pad. A transporter pulls in. On the platform, sedans, a pickup, an old hybrid that's seen better days. A technician scans each VIN, photographs the condition, and logs a digital record: model year, engine type, drivetrain, airbags deployed, catalytic converter present, battery type. This isn't just paperwork. It's a value map, a blueprint for what we can save and what we can transform. One of these cars will yield a small fortune in reusable parts. Another will give more in pure metal. Which one? We'll find out. But first, the critical step that makes everything else safe: making a car harmless. Before a wrench turns or a bolt moves, technicians de-energize the vehicle. For gasoline cars, the lead-acid battery comes out first. For hybrids and EVs, high-voltage packs are disconnected using insulated tools and strict lockout procedures. These packs don't get tossed. They're handled like small power stations, isolated, crated, and shipped to specialized facilities. Now the depollution bay. A car still holds liters of fuel, oils, coolant, refrigerant, and brake fluid. A steel lance pierces the tank. Hoses hiss. A vacuum system pulls out every last drop into sealed reservoirs. After filtering, much of this reclaimed fluid is reused on-site to power equipment. The rest becomes a controlled input for other industrial processes. Only when a car is safe, electrically silent, fluids gone, does the real surgery begin. And some parts, they're more valuable than you'd expect. The parts that refuse to die. Think of the car as a layered puzzle. We remove the big, bulky pieces first: wheels and tires. Rims get fast-tracked to metal recycling. Tires, which resist decay for decades, are shredded into crumb rubber for playgrounds and asphalt blends, or used as a high-energy industrial fuel. Glass. Windshields and side windows are laminated with PVB, polyvinyl butyryl. Specialized cutters release both the glass and the PVB, which can be reborn in soundproofing and coatings. Doors and interiors. Doors aren't just panels, they're wiring looms, window motors, locks, sensors, plastics, foams, textiles, and airbag modules peel away in a sequence that looks chaotic but is obsessively planned. Copper and electronics. Wiring harnesses are stripped for copper, a metal that keeps its value, in control modules, sensors, and ECUs join the booming market for tested, warrantied used parts. Then we reach the heavy hitters: the engine, transmission, and the catalytic converter. Engines may be remanufactured, transmissions get refurbished, and catalytic converters, packed with platinum group metals, are meticulously processed because each gram is worth it. So, what part of a car survives almost every crash and still commands a premium years later? You're thinking of the engine. Smart guess. But the catalytic converter, that quiet stainless can under your car, can be the sleeper hit. The brutal beauty of reduction. Now the vehicle is a skeleton, mostly steel, some aluminum. A hydraulic shear, imagine a steel T-Rex jaw, rips off anything that would contaminate the melt or jam the crusher. What remains is clean, smelter-ready metal. Time for compaction. 3 main approaches. 1. Car baler. Compresses the body into dense cubes, easy to stack, efficient to ship. 2. Flattener. Squeezes the car into a low, wide slab fast, lower energy, ideal for smaller yards. 3. Shear baler. Compresses and chops, feeding the next stage directly with bite-sized pieces. A pile of cubes heads for the shredder, the thunderous heart of the line. Inside, counter-rotating shafts with interlocking teeth tear metal apart like paper. In minutes, a parking space-sized car becomes uniform fragments the size of a fist, then smaller, perfect for sorting. But how do you separate a storm of mixed metals at industrial speed? With physics and a little magic. Sorting at the speed of industry. After shredding, conveyor belts carry a stream of mixed material. Magnets pull out the ferrous steel first. Eddy current separators induce currents in non-ferrous metals, flinging aluminum and copper out on a different trajectory. Air classifiers and screens whisk away lighter residues, plastics, foams, fabrics. What's left is clean feedstock: steel for the furnace, aluminum for secondary smelters, copper for wire mills. From one end-of-life vehicle, you can recover a surprising proportion of its original mass in metals, ready for a second career. And now we reach the moment where scrap becomes steel again. No romance, just electricity, chemistry, and heat so bright you feel it through a camera lens. Lightning in a furnace. Welcome to the electric arc furnace, the EAF. Graphite electrodes lower into a vessel loaded with scrap. With a crack and a glare, an arc leaps between the electrode and metal, tens of thousands of amps, carving a tunnel through the air. Temperatures rocket well past 1,500 degrees Celsius. The charge slumps, then flows a glowing lake of liquid steel. Operators add lime and flux. Impurities migrate into a foamy slag layer. Oxygen lances burn off unwanted elements. Probes and spectrometers sample the melt, nudging composition toward exact spec. Carbon here, manganese there, alloying elements tuned to future orders. When the chemistry is right, the furnace taps. A torrent of molten steel pours into ladles and then into sealed channels, feeding the next miracle. Continuous casting, from liquid to logic, casting and rolling. In continuous casting, molten steel flows into water-cooled molds and forms a solid shell almost instantly, while the inside stays molten. Rollers support the strand as it snakes forward, cooling in a controlled gradient. Then thermal saws cut the strand into billets, square, blooms, rectangular, or slabs, wide and flat, each destined for a different life. Reheat furnaces bring these shapes to exactly the right temperature. Then the hot rolling mill takes over rows of massive rollers, reduce thickness pass by pass. Billets become rebar. Slabs become coils and sheets. Throughout, lasers and cameras measure thickness, straightness, and edge quality in real time. Freshly rolled steel must cool smartly too fast, and it cracks. Too slow, and properties drift. High-pressure sprays and controlled air cooling lock in the mechanical profile. Final inspection uses ultrasonic testing, visual cameras, and tensile samples to certify quality. That's the end of the line and the start of 1,000 new products. Where the steel goes next. Coils head to automakers to become body panels. Plates go to bridge decks. Bars and beams rise as apartment frames. Rebar strengthens foundations. Some will become machines that build more recycling plants. Some full circle will return as new car frames. Here's the quiet superpower of this system. Every loop saves energy, cuts emissions, and reduces the need to blast fresh ore from the ground. Material that would have rotted behind a chain-link fence is now part of a city skyline. But remember that hybrid we met at the gate? Its high-voltage battery didn't vanish into a black box. There's a second loop in play, the battery side quest. Those lithium-ion packs go to specialized facilities where they're discharged, dismantled, and separated into foils, plastics, and black mass. A powdery blend of valuable metals like nickel, manganese, cobalt, and lithium. Hydrometallurgical processes recover them for new cells. It's a younger ecosystem than steel, but it's scaling fast. Tomorrow's EV may carry atoms that powered commutes a decade ago. The big picture. A car is a complicated promise, thousands of parts moving in harmony. But its second life is simpler, more elemental. We reduce it to what matters and rebuild the world. At the gate, data. In the bay, safety. On the line, parts that live again. In the shredder, controlled chaos. In the furnace, lightning and liquid structure. On the mill, geometry and precision. At the end, steel with a future. So the next time you drive past a construction site, look at the beams and ask yourself, how many lives did that metal live before this one? If you want more deep dives into the hidden machines that keep our world moving, hit subscribe, drop a comment. Which stage surprised you, the shredder, the casting, or the battery loop? And if you've got a factory you want us to visit next, tell us below. I'm the factory line, and this is how recycled car is made.